on the problem number 24 on kinematics. So it says a bus traveling the first 1/3 distance at a speed of 10 km/h. The next 1/3 at 20 km/h, and then remaining at 40 km/h. The average speed of the bus nearly is how much? So the bus is traveling in the one and it is moving on a straight line. This is distributed in 3 segments: 1/3, 1/3, and remaining 1/3. The first 1/3 having a speed of 10 km/h. Second one has 20 km/h. Third one is 40 km/h. So average speed. So as you know, the average speed is the total distance. So let me take, it is 3x distance. Okay, 3x distance. So first one, so this will be on the top, that means in numerator, that is total distance 3x, and the time, total time. So respectively the time for first cases will be x by 10, distance upon velocity. For second case x by 20, and for third is x by 40. Okay, so now if you calculate, x will be eliminated. On the top 3 will be there, and here it will be 1 by 10 plus 1 by 20 plus 1 by 40. So now if we calculate, this will become the numerator, the LCM of all this 10, 20, 40. If I do that will come 1, 2, 40. Okay, so 10 will be 4, 22 plus 1, and the top 3. So now after calculating, it will come 3 into 40 on the top, and it will be 7. So this will all be, almost will be 12 into 10 by 7. 12 by 7, if I divide, approximate value will come 7 sevens are 49, 1.7. So 1.7, and then after 1 will come again, 1 may come. So 1 into 10, so approximately 117.1, and the unit would be km/h. Okay, so moving to next problem number 25. If a car covers first 2/5 of the total distance with the speed v1 and remaining 3/5 of the total distance with the speed v2, then find average speed. So assume this is total distance, let's say this 5x. So this first part is 2x and second part is 3x, as it's 2/5 of the total, 2/5 the total of 5x. I am assuming just to have the calculation easy. So the first velocity is v1, second one is v2. So S average equal to total distance 5x upon 2x by v1 time, and here 3x by v2 the time. So it will come, x will be cancelled out, 5 upon 2 by v1 plus 3 by v2. So this will become 5 upon v1, v2 will be on the top, and here 2v2 plus 3v1. So this will be the answer. Okay, 2v2 and 3v1. Okay, moving to next. (26) A body has a speed v, 2v and 3v in the first 1/3 distance in consecutive. You can say first 1/3 distance and second 1/3 distance, and the remaining of the total distance, and remaining of the total distance respectively. Its average speed, find S average. So this is same as the last to last, the 3 segment of the path, 1/3, 1/3, 1/3. Let's say it is 3x total, so it will be x, x and x, and the velocity is v, 2v, 3v. So again S average will be 3x upon x plus x by v time, second is x by 2v time, third one is x by 3v time. So if I calculate, x will be cancelled out, 3 upon this v will be the LCM, 3v will be LCM, so 3v will go up, and here as it is 3v, so here v, that means 3 will come here, plus 2 will come here, 1 will come here. So 3 is a 9v divided by 6, 3, 2. So ultimately 3 by 2 v will be the answer to this question. Okay, moving to, as because these are similar, I am not taking too much time to make you understand. Already I have explained how to do it, so I am going fast just to give you some impression. problem, if you practice at home, it will be easy to solve at any point of time. A car travels from station A to station B at 30 kmph kilometer per hour during return trip to A. It travels at 30 kilometer per hour for first half of journey time. Okay, it's not that the first half of the distance, first half of the journey time, and at 70 kilometer per hour for next half time. Okay, next half of the journey time and the next half time. Find average speed and average velocity. You have to find average speed and average velocity. Now understand the problem. This is a bit different. A car travels from station A to station B. Means the journey starts from A and going to B. This is the normal journey. But what is happening here? From station A to station B at 30 km per hour during return trip. It's not that forward trip the information is given. It is given for the return trip. When it is coming back from B to A, it is moving at 30 km per hour. Okay, that whole distance during the return trip. So you have to read this perfectly, or otherwise you will be confused and start calculating the same thing this way. It is written in the other way. When it is returning, it is having a same speed 30, and it travels at 30 km per hour first half of the journey time and 70 km per hour the next time. So journey time means this is not the return trip. Journey time is when it is starting from A to B. So the first, let's say the total time is 2t. So first t he is moving with a 30 km per hour, and the next t moving 70 km per hour. This is the information given. Only returning back. So obviously if we calculate V average, as because he is coming back to the same point, so average speed will be average velocity will be 0, because there is no resultant displacement, that is nullified. So only we will concentrate on the speed. So average speed is equal to nothing but the total distance. Total distance we assume at 2x. If it's x, we can say the total distance x upon the time is what, the total distance is 2x, because x I have taken for any forward journey. The return journey always, the total journey will be x plus x 2x, and the time is, for this case when it is moving with 30 for t time, the time is taken t and the return time. So here if I assume the t, the velocity for the time is, let's say t, that will be 2t, and the time for this is equal to plus x by 30. So now if the total, so for this forward journey, if there is 2 speed is there, so the average speed for the forward journey, if I calculate first, it will be that the time is equally divided, so that will be v plus u by 2. As we know, if the two velocities are there equally distributed by the time, then the average speed for the forward journey will be v plus. So here I will get 30 plus 70 by 2. So that means 50 will be the velocity, average velocity for forward motion. So that t, we can say that the distance traversed by x with a velocity 50 and time is 2t I have taken. Okay, so if it is 2t, then x is equal to t is equal to x by t, I can say, or 2t directly, x by 50 you can say, because 2t will come here. So x by 50 for the forward motion, and for backward motion the speed is 30, you know, that will be divided by x divided with that. So x will be cancelled out on the top, 50 into 30, and here is 80. 50 plus 30 will come, so 4, 150 by 4, so that will come around 37.5. So and the unit, it is in kilometer per hour, so that will be so. So the main fact you have to understand here, for the forward motion there is two velocities, so time is not given, distance also not given. So for that case, there must be one velocity, that has to be the average speed by which, if it traverses for the same time, it will cover the same distance. So the speed by which the two speed can be converted into one speed, and for that there will be no deviation for the time and the displacement, it will be the average speed. Because if I consider that time is distributed equally, so the distance x1 plus x2 is what? Is the total distance. Now x1 x2 is equal to speed into time plus speed into time, that we know. So that is what? 100 into time, so that is the total distance x. So your time is equal to x upon 100, but we have taken 2t because t and t, so 2t will be divided into 2, so x by 50. So from there also you can calculate, because you know, if time is equally distributed, the equation is two velocities by time. So this is the trick here. For forward motion you cannot go with the two velocities, so you cannot able to get that equation with in terms of x, because neither x you know, distance you know, nor the time. So this is the trick here. So you have to be concentrated on that. I think you have understood what I have done. I have just calculated first the average velocity during forward motion. So the speed average for the forward motion is u plus v by 2. So that is 30 plus 70 by 2. It gives 50. So now I have only single velocity for forward motion. So time will be, if I assume it is x, so x by 50, and backward motion x by 30. Now that is the same. If the total journey brings into the same position, the rule you know. So already I have solved so many problems, so you can follow it. Coming to the next, 28. There is a hexagonal path, that is a regular hexagon, that means all the sides are of equal length. So those are named as A, B, C, D, E and F, and the velocities along the each path is given as V this way. You just follow the direction V, this direction this way, but velocities are of equal magnitude. V, this is V and this one is V. So these are the diagram given. So problem says a body is moving along the regular hexagon, hexagonal path as shown. Find the average speed. You have to find average, S average and V average of the body for A to D. So for the body, you have to consider A to D. For this travel, how much is the average velocity? So for velocity, if I consider, I have to consider the shortest distance. This is the shortest distance, and what is the value for that? If I say the average velocity here will be the total displacement upon time. This is displacement upon time. Okay. So the body is moving another expression. So what are the things given? Velocity is given only. Now as the distance are 7, let me assume that each arm is of length A. I am assuming that each arm is length A and the velocity V. So time taken to travel each arm will be always A upon V, because V's are same and A are same, so time is same. Only thing you have to consider displacement. So displacement is, how to calculate this one? If I drop it, the velocity, if I drop the perpendicular, now this is BC is equal to this one, and the remaining this part has to be calculated by the formula. This one is equal to this plus this, as because it is uniform, then you can say, see, this and this together will give you the part, this one, because this is uniform one. So the displacement here, it will come, this arm is A, so this total will be 2A, the diagonal, or let me do it in other way. So this length you don't know, this also hexagonal, so hexagonal means the displacement. I have to calculate the displacement, or will come, if I take the center of this and if I join all these vertices, this will form a equilateral triangle. Okay, so let me draw this, because if the center, if it is irregular, so this will form a equilateral triangle. If it is A, then this has to be A, this also to be A. So that way the total displacement will be the direct distance between A to D. So this is 2A, and the time is A by V plus how much the time will be, A by V and A by V. Okay, this total time will be taken, and whatever the way the displacement covers, it will cover this total time. So A by V, and but this case the displacement time is scalar, so I will not take the direction, although this velocity has the opposite direction. So during time calculation, because A also displacement, so displacement for this case velocity is opposite, so then that case you have to consider, but time is not the time is not the case where the sign to be taken. So this will be 2A upon 3 of A by V. So A will be cancelled out, so this will be 2 by third of V. So your average velocity will be 2/3 of the velocity, and for A to D, the S average will be the total distance covered. So distance will be followed by the arm of the arm of the hexagon, so that will be a plus a 3a, and the time will be same, 3 into a by v, so a will be cancelled out, so this will be v, so s average will be v and your v average will be 2/3 of the v. Okay, so this is the requirement of the problem. So this is for today, and the next day I will bring the next problem for you, that is problem number 28 and onwards, and the chapter 18. Okay, so good night for now. Just go on my go and see my videos that I've uploaded already and learn from that. If anything comes in your mind, any doubt, you can put it in your message box. I will answer it. Thank you.